Hi, this video is about naming molecules, which are covalent compounds. It's lesson 2, module 7. So we know, this is kind of review, we have a lot of oxyanions on our pink sheet. You can see almost all of these ions, these polyatomic ions have oxygen, so they're called oxyions. There's a couple that don't, but anyways, when you name a binary molecular compound or a covalent, these are always going to be for two nonmetals that are together. And example, kind of a why this is necessary is, for example, CO and CO2. The first one is called carbon monoxide, which is a poisonous gas that can cause people to die. And the reason why is because it bonds really tightly to your hemoglobin and doesn't allow your body to transport oxygen. Very different than carbon dioxide, which is really common. We exhale carbon dioxide all the time. So the rules kind of for naming, first thing you do, like if you have a compound like this, is you just name the first ion normal. So we would say nitrogen. The second element, the oxygen, would be called oxide. So similar, that would be how we would name it with ionic. But now we're going to use prefixes, and we have these on our pink sheet on the left side. We're going to say dinitrogen to show that we have two monoxide. So mono means one. And we the only time we don't use a prefix is when we only have one of the first elements. So notice the carbon monoxide, I didn't call that monocarbon monoxide, but I do use the mono on the second element if I only have one. Writing the formulas are really pretty easy because you just take the name and you take the prefixes. So like this would be P for phosphorus, and hydride is hydrogen, and then di is 2, and this is 6. And then also just a pointer thing that you need to know is that we don't reduce when they're covalent. So we wouldn't change that to pH 3. So example here, naming this compound, we know we have phosphorus, and oops, I'm spelling it wrong. Sorry. Just looking at my periodic table. Phosphorus. So phosphorus, and then we have oxygen, which becomes oxide. We're going to put a di for the 2 phosphorus and a pent. And we drop the A on the penta when we have 2 vowels together. So pentoxide. Here's going the other direction. This one's really kind of similar, so maybe I'll change it to dinitrogen heptoxide. So this would be in N2O7. The hept would mean 7 oxygens. So now we're going to talk about acids, and they fall under this category of molecules because they're covalently bonded. Acids are always going to start with hydrogen, and they are, we're going to learn a lot more about them. When you add them to water, they release hydrogen ions, but we're going to learn a lot more. But for now, we just want to be able to name and write their formulas. So you can have, and this is on your pink sheet to help you also, binary acids are when you have just 2 elements. For example, HCl, we would call that hydro. And then we put the stem of the anion, chlor, and then we put ic, and then acid. So you can see, right, here's where I put the root of the anion. Oxyacids are when you're going to use your pink sheet and look at the polyatomic ions. And we're not going to use hydro when we name oxyacids. So let's do some examples. So example here, we're going to name the binary acid HF. So I know it's an acid because it starts with H. If the H comes second, then it's not an acid. This is binary, so I'm going to do hydro. And then I'm going to plug in that fluor. And then I'm going to put ic acid. So hydrofluoric acid. Oxy acids. So here, let's do, I think I have another, yeah, this is an example of an oxy acid. So anytime we know it's still an acid, and then the other part is a poly, atomic ion, and it contains oxygen. That's why we call it an oxy acid. So that's where you're going to use these hints. So the first thing you want to do is locate the polyatomic ion on your pink sheet. This is called oxalate. And then you think about what I have over here. So if the poly ends in ate, we change it to ic, and then we add the word acid for both of those. So this would become oxalic acid. So notice no hydro. Writing the formulas now the other way. So if I know the name and I write the formula, I have to look up the charges of the, well, I know hydrogen, and look it up if you forget, it's +1. And then here I'm going backwards. So I'm looking at this, and I know that that is iodine, and I know iodine is -1 because it's in group 17. So these already add up to 0, so the formula is just going to be HI. Similarly over here, again, I know I have a binary acid. There is not a polyatomic ion. So I know I'm just looking for that element, and I'm going to put sulfur with the hydrogen. I'm going to crisscross this time, and it's going to be H2S. So you do have to make sure that the charges add to 0, just like an ionic. Here is another example, hypochlorous acid. Hypo is not to be confused with hydro. So we're really reversing backwards. We're looking at us, and we know it came from ite. So I'm going to look on my poly sheet, and I'm going to try to find hypochlorite. And that is ClO with a negative. And then I know it's an acid, so it's going to always start with H. And you can see that these already add up to 0, so my formula is just going to be HClO. So here's an example now of writing the formula. Again, this one's hydronitric, so we know it's binary. That means it doesn't have oxygen, so I'm looking for nitrogen. I know it's an acid, starts with H. Nitrogen is -3, so formula is H3N. So kind of the problem, that can happen is it gets a little confusing because they all have different rules. So let me just summarize a little bit. Ionic compounds are always going to be between a metal and a nonmetal. And or there'll be a polyatomic ion. Covalent is between two nonmetals to the right of the stairs, but also including hydrogen. Acids are always going to start with hydrogen. So when I name, I don't use prefixes when it's ionic or if it's an acid. I do use prefixes when it's covalent. When I'm writing the formulas for ionic, I do crisscross. Covalent, I do not crisscross. And for acids, I'm always crisscrossing the hydrogen with something else. So I do crisscross. When I write the formulas, I do reduce the subscripts. If it's ionic, for example, like if I have Pb2O4, I would reduce that to PbO2. I do not reduce for covalent. So if I have P2O10, I do not change that into PO5. And then that doesn't really apply to acids. So hopefully